going to talk about making graphics and music, but it was led by Marcus, who wanted to learn a bit more about how graphics and sound was produced on these 8-bit micros. And so we decided to have a little bit of a play with it so you can get used to, the theory behind it. It's not massively in-depth, but it just gives an overview of how sounds and graphics were produced initially on these machines. And it's quite nice to step back in time and remember how much work and effort went into making these machines do something, and also how much it's actually still used today in not so much the computers themselves, but other pieces of hardware we don't even realize that the old 8-bit processors are still being used in. And one of the things is MIDI. MIDI is predominantly 7-bit, and so the processors can quite happily be 8-bit based and sort of plod along quite merrily and do everything you want them to do. But this was predominantly a look at some of the basic graphics and how we did things and how we did sound as well on these older machines. So I hope you enjoy this, and let's have a look.
Today I am going to start learning how to do graphics. It's going to be using on a BBC Basic.
Okay, today we're going to start with graphics. It's a very simple little man using the BBC Micro and BBC Basic. And to do this, we're going to use the BBC Basic command of VDU. And if you notice, all of the characters, because we're using an ASCII set, it works on a grid pattern. You've got A to H down the left hand side, and along the top you've got basically 128 to 1 if you're reading it from left to right. And each character can be changed, and the way you change it is you map the individual pixel on the grid. So basically, if you look at the line at the bottom, the VDU23 is the command that you're using. The rest of the lines actually tell you where you're putting the pixel on the screen itself or within the character you're creating. So for example, this character here, or the first line of this block, you are filling in 4 different blanks. So you start off with 16, 8 and 4. Now if you add those together, okay, that's how you create the first 4 pixels within this character set. And as you do it, you work your way down the grid, all the way down the grid, doing exactly the same until you get the character you desire. Now we're going to do this. It's how basic graphics started off.
We're going to turn an ASCII character into a running man. I'm going to run this, and then we're going to go onto the real hardware. Sorry? We got 1 man now, and now we're going to make him run.
If you get down here, how it works is you got mode 4 is your graphics mode, your video mode for the resolution of the screen. And that's your character you're making, your little running man. That's each one of those is a
running man.
Is where you put the dots on the square to make up the character.
Okay.
Now for X, okay, is 1 to 19. Okay, so what it does, you're setting X from 1 to 19, so that's now X. Its range is from between 1 and 19. Now what you're doing is you're printing each time x comma 10, so it's going to be position 1 comma position 10, and then it's going to print the character screen. Okay, so the next time it runs it, it goes position 2 on position comma 10, and then the character string, then position 3, and so on until it gets to 19, and it moves the man across the screen. Okay, so do you want to try it?
Yeah.
Go on, if you go, press run.
So return.
Yeah.
And return.
Wait,
Right.
there's your running man. So if you type list, okay, so that's how it works. Okay, so what it's done is it's printed every single man across the screen on that character there, X. Can you see how it works?
Yeah.
Right, so that's a computer. That's how you do normal small little graphics. They're called character graphics. Okay, so all you're doing is taking a key and redefining a Y into a man, or a U into a man, or an I into a man, and so on. Okay, you're changing the character for that key. Okay, so what you can do on these computers is, when they start to develop graphics, is to use different commands to do different things. So you can do lines and triangles and things like that on command, rather than printing all of these characters in, all of these numbers in, to make a character in a square.
Wow.
Okay, so remember, it's built out of a square, isn't it? So what we're going to do is show you how to do that. Now sometimes you don't want to do a character to run across the screen. Sometimes you want to draw something, and there's a command for that. So if you type in draw, AW space, and if you put 130 comma, say 100,
100.
what do you think will happen now?
It's just going to draw like a straight diagonal
Try it.
line.
Just try it.
Time?
Okay, so it draws a starting point of 130 and how many basically pixels it wants to go up the screen. Okay, so if you add in draw
G R
space 200
2
comma 400, what it will do is change the angle and the length. So press return.
Whoa, that's like a tick, but the
Yeah.
wrong way.
Yeah, but you can see how easy it is to actually draw shapes on the screen, rather than having to do lots of little commands to
Like
make a
this.
tiny little man. So can you see how it works? Rather than doing every dot like you did to make the man, you can now tell the computer to draw a line from point to point. Now how much easier is that?
Much more easier.
So if you do draw, just another example,
DRAU
space
space
400 comma 200.
2.
Okay, it's going to start off. There you go. So what you're doing is you've started off 130, 100, 200, 400, 400, 200. So if you wanted to add another line, you'd pick up that point there, which is, what do you think that's going to be?
Draw 200. No, 200, 500.
Yeah, start off at 200. So draw space
Space
200
200
comma and then 200, comma, put 500 in. Press return. And you can see it's coming, starts from that point to wherever you want to send it to, that point, which is 500. Okay, so it's a lot easier to draw using the draw command than it is to plot every little pixel on the screen. But you can't, the downside is you can't move this whole sort of big W around, which is what it looks like, on the screen as one thing, like you can with a character, because it's a lot easier. Okay?
Yeah. Like if you type something in and then a whole row of characters went all across your screen.
Yeah.
You can't do that with the
No.
W.
You can draw point to point, and it helps you create graphics. Another form of moving your cursor around the screen is a basic command called move. So if you type in move, M-O-V-E,
M-O-V-E
space,
space,
let's try 100,
100 space,
comma, 300,
300.
and press return. Okay. What do you think that would have done?
Nothing?
No,
No, it might have made a line.
it moves a start point for your cursor or pixel for where you want to draw something, okay?
Okay.
Okay, so now if you type in draw,
T-R-A-Y
W,
W
space,
space
100, comma, 300.
All the same.
Press return. And what do you see on the screen?
Just another line.
No, look very closely. Do you see a little white dot?
Yeah.
Where? Point it out. Right, you've told the computer to
do a
move to that point and then draw that point.
Draw a dot.
So there's your point, there's your starting point. Okay. So if you type in move, space 100, comma 200, press return. Right, now draw 100, comma 200,
Where's T-R-A-Y?
W,
I
100, comma 200,
100, comma 200.
press return.
Return. Oh, there's two dots.
Yeah, the second dot is...
What about this move 100?
Yeah, the second one is you've told it to move to that position and then draw that position. Basically, it's just plotting the dot. Okay?
Right there from there.
Yeah. See? So that's how you start to put things on the screen before you draw anything, okay? Does that, yeah? And you can also use it to start putting your little running man there as well. You're going to tell it to move to that position and start to draw the running man.
Whoa.
So that's how graphics on a computer start out.
Okay.
So, show you how to do sound. Okay, we're going to show you how to add sound onto this machine. So it's very simple. It's the sound command. That's so sound. So if you type sound, S-O-U-N-D.
S-O-U.
Yep.
Well, yeah. U-N-D.
And space.
Out.
And then space. And then we're going to use channel 1 because this computer has 3 channels. So press 1, channel 1, comma, and then how loud we want the sound to be. So put minus 15.
Oh yeah.
Yeah.
Minus 15. 1, 5. Oh.
Okay.
1, 5.
Comma.
Comma.
And then the pitch, we'll say pitch of 52. So 5-2.
5, 2.
Then a comma.
Comma.
And then how long we want the note to play. So 20, 2-0. Now press return. Okay, so if you want to make that sound longer, if we use the copy key, you could change that to
22.
30.
30.
And then it lasts longer, doesn't it? Now, so if you want to make that sound
Longer.
a different pitch, so a different, how high it is, yeah,
58.
okay.
50.
Can you see how that goes up? It sounds different. So if you want to make, yeah, so if you want to make that sound,
59.
let's say we'll go up to it, let's change it, 68. Okay, see how that works?
Yeah.
So now if we turn this into a little program by adding line numbers to it, we'll see what happens, okay? Right, so now you've copied all of the lines and it's now a program. So type run and let's see what you've done.
R-U-N. What time?
There you go, there's your first sound you've written on a computer. What do you think?
Great.
So there we have it. We have the start of possibly the video game industry as we know it today, with its graphics, its sound, and it all started from little micros like these. But today we don't seem to use sound chips anymore. Everything's sampled and recorded because we have the memory to do it. Which is a shame because some of these machines produced really good musical scores. So now the programming and the principles are still the same whether you did it on a sound chip on a BBC Micro or a sound chip on a Commodore 64. And it's all about putting in the length, the frequency, the tone, the attack, the delay and so on to get the music you want. Can you see how the music works? Yeah? So the notes you were doing, you can make music like this.
Okay.
Can you hear the different notes?
Yeah.
How many sound channels do you think there are? Is it 1, 2 or 3? 3. Can you hear the different notes at the same time?
Yeah.
So do you know when you're on the BBC and you put channel 1, well if you did channel 2 and channel 3,
At the same time.
you get different harmonies.
Yeah.
So the program's already written on this, so instead of typing the program in, you can use this top row of the alphabet keys, QWERTY keys, and you can press and make your sounds. Off you go. Can you see how it was the same, but the notes were already done as a program, and
Yeah,
all you were doing?
Lower notes like a normal one, and then higher notes.
Yeah, and that's how you did your. That's how you did your program. You started off and you added each tone as you went up. So you had 5 tones going on your little
5?
program. Yeah, it went up, up, and up, and up, didn't it?
Yeah.
But this one, because the program's already there, you can press the keys to make the sound. It's the same way of doing it, but you're just pressing a key instead of typing the notes in.
Yeah.
Now to make it easier,
You can have your own keyboard.
we have
Wait, can we do it? Can we do it? Can I have a go?
and you press
Can I have a go?
all this.
Can I
Okay,
have a go?
so off you go. Have a go with the keys. So the way the BBC works is you have one, okay, one, and then you can have two and three. You can't have a
Can't have 4,
or
5.
no, because it's a three channel system. So if you do okay, you can see the 3 voices working there. So you try with 1 note, then add 2, then add 3. Okay, so can you see how that works now? You see how it works? Now the Commodore 64 has 3 channels, as we say. You got 1, 2, 3. Okay?
Because you can't have 4, 5, or 6.
No,
or
but
7.
it makes it polyphonic. That means you can play more than one note at a time. Okay? Now a ZX Spectrum only has one channel. So this ZX Spectrum here, okay, can only play
A.
1 note at a time. So it can go, but it can't go. Okay, so that's why the sound chip in a BBC Micro and a Commodore 64, and even a VIC-20, is a lot more superior to a ZX Spectrum.
Wait, can channels go only up to 3 or higher?
No, you can have as many channels as the chip or the sound chip or the processor can allow. Modern or later synthesizers could have had 8 channels, so you could do 8 at a time.
Like,
But most computers at the time had either a 1 voice or a 2 voice channel.
Or 3.
Very few had a proper 3 voice channel. Okay, which means that on a 3 voice system like this, you can get much better sound than you could out of
It's really actually better when you use like 3.
So a lot of the computers at the time just had 1 voice. The Commodore 64 on the other hand had 3 voices plus a noise channel, okay, to help with sound effects. And that's how games and programming with sound developed. But it all developed from those few little lines that you did on the BBC Micro. Okay, everything that you hear here is a program written in a similar way to what you did, but it means that when you press the key instead of typing run, it does that sound.
Whoa. That's cool. That's super cool.
So the program, the way they're written, okay, is instead of typing run for each instruction, the program's running, telling it if you press this key to make that sound, this key to make that sound, this key to make that sound. So you don't have to type run, but it was the same as what you did.
Yeah.
By typing the instructions.
And if you like press a button, yeah, like it actually makes a sound.
Yeah.
Like if you were to press A, or like a high note A, and then if you press a low note A, it'll just go really low.
Yeah.
It's like low bit and high bit.
Yeah, and that's what you did. You went from low to higher on the little program you wrote.
You're like, I was like dun 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 dun. Like from highest to lowest notes.
So that's how you program things to do things like this, the way you would earn it. Okay? That is just a program. Okay?
That's just a program.
Yeah, that does that sound. Okay? And that's just a program in the same way as this, my synthesizer here. Okay? Does exactly the same.
Yeah.
Because there's a computer inside of it that makes the notes. So if I so if I switch it on and I select, let's have a look, piano, and I just do some, okay, it's exactly the same. Okay, it's exactly the same as the program that you do on here. Okay?
Yeah.
This is a computer.
And the principle is the same.
Yeah, this is a computerized keyboard. Okay, so inside it's got a computer, and that generates sound via a sound chip, exactly the same as is on here. So the sound chip and the sound chip is the same, but this, the amount of voices that are on that keyboard because of the Commodore is 3 voices. Yeah. Okay.
Yeah.
3 voices. Right, now listen to this one. Listen to this one. There's 2. There's 3. There's 4. Now if I add in a bottom one, 5, 6. So this one you can do a lot more voices. You can have 8 or more voices running on a keyboard.
Because if you do 8 on here, that would
it doesn't
sound
work.
good.
It doesn't sound at all. You only get 3 voices.
Yeah, like this. Like if I was like this.
Yeah,
Yeah,
3 voices. But you got to remember the Commodore 64 isn't a synthesizer. It isn't a keyboard as such.
Yeah.
It was designed to produce sound, and it was designed to produce sound for games.
Yeah.
Okay? And you can do a lot with it. So now, having looked at how sound and graphics were initially produced on these 8-bit machines, as I said, it's not massively in depth, it's just an overview. We'll go into more of the structure later on, but it's one of those things. It's kind of the land that time forgot, because nowadays everything's sampled. Character graphics no longer really apply these days unless you're actually producing keyboard maps, and also chip tunes or SID chips and sound chips and so on are no longer used predominantly in the world of computers as much. It's all sampling, high bit rate, high frequency, and so on. So we've moved on as far as the desktop computer is concerned, or your laptop, or even your mobile phone. But what we haven't moved on is instrumentation and other machines that are out there that still use a version, or at least the principles behind a sound chip, a synthesizer chip. So I hope you've enjoyed this, and I hope you subscribe, and we'll do some more on this channel in the future on the computer program.